Today's episode is about how we turn agent traces into event logs. We will also be talking about our two standards, which are XES and OCEL 2.0. So, a small recap. Here we have our trace. So as you can see here, we have different actions that were taken by our agent. After that, we need to flatten it because that's the input for process mining. Your trace you run will be allocated the case ID. The operation will be the name of your activity. Also, you have the timestamp when the span started. For example, when chat happened will be the timestamp. Also, here for the resource, which is usually the name of the person that took an action in your organization. In this case, it will be the agent or the ID of the agent. One thing to be clear-eyed about is that there is no convention that says, okay, this is how we do it, or there is no rule. This is more like a convention that was created from practice from different engineers who needed to do this before. So there is no document that sets this in stone. But the mapping is very easy if you do it this way. Now, when doing this mapping, you actually have a choice, which is your granularity. So the question is, what counts as one activity? So it's a dial. You're gonna go from here, from left to right. Because if your two cores, you're on this side, and you collapse everything into a couple of generic activities, you get what we call a flower model. So this is what we call a flower model. And what this means basically is that it's permitting everything. You're underfitting and you're allowing your agent to do any behavior it wants. So there is no conformance here. On the other side, if the mapping is too fine, then you're mapping every row span, every retry, every internal call, and each one of these becomes its own activity. Every run becomes unique, which means this is overfitting because what you get is a spaghetti diagram. So you have too many nodes, you have too many arcs, so nothing is shared. It's not readable. You can't analyze this. The skill here for an engineer is the tuning, the dial between here to here, where to put this point. At the operation level, you have search, evaluate, refine, answer, and the refinement loop is legible without shattering into noise. So this isn't really hand-waving or trying to avoid the question. This is the core finding of event abstraction survey in this paper. And the idea here is that you getting data to the right granularity is vital for process mining, for any process mining work. So in another episode, I've spoken to you about the following standard. And I've told you that this standard, what we call XES, it was between 1849, so it's pretty old, and it was revised in 2023. One thing to remember, if you have your data in XES, you can do the mapping between concept name, because XES is a tree actually. So you can have your agent span in XES format. The following will map to activity and case name, the timestamp, and org resource will be the column that represents who did it. Lifecycle transition will represent when your action started, finished, of course. So one thing to remember is that in the case of process mining, only these columns are necessary. So it's the case, the activity, and the timestamp. The rest are optional. All the other columns, when you're flattening, you may have them, you may not. It's really depending on your event or on your object. And one thing to remember is that each event exactly maps to one case. That's the limit here we have. So that single case situation was solved by another standard, which is OCEL. If you need more explanation about how OCEL works, please check my other video. I actually have a 10-minute video on my channel that explains that precisely. And the mapping works plainly in the same way. There is no document, of course. The idea here is to make something that makes sense. Other engineers did it before. The idea is to copy more or less what they did and what was successful. So for the conversion and for the flattening between XES to your data, to OCEL, for example, you can actually use PM4Py. And as we have seen already, this is already supported by PM4Py. The problem here that we have is that PM4Py will not choose the granularity for you. This is something you need to do actively yourself, and this is something you can only be able to decide if you know the case precisely and where you're applying your granularity. So it's really a play of trying. You just try different granularity levels. You see which results, how your agents will act in different situations, and there is also simulation. You can simulate how your agents would work, and it's not really a 100% solved question. So there was actually research about precisely the subject. So IBM took a Crew AI calculator and ran it 290 times on a fixed input. And they did the following calculation. So the calculation is very simple. You have 1 plus 2 minus 3 multiplied by 4 divided by 5. And you have 3 agents. You have your decomposer, calculator, manager. Now, as usual, you have your case, which will be the run number. The activity will be the agent plus tool concatenated, and they together will give the name, as you can see here. And what happened is that when they ran the heuristics miner on that log, this happened. On some runs, the calculator agent invoked an evaluate parenthesis tool. So, which means here, what happens is that actually a tool fired when it should have never fired. And actually there was another issue that their causal discovery view caught a second bug. The manager agent invoking the math tool did it directly instead of delegating them to the calculator, which means the manager took over the job of the calculator. So this is what we call a breach of responsibility. These are two behavioral bugs that you could prevent with a good choice of granularity. So the issue here basically is that they chose a sensible activity granularity and mined the log too precisely. They were too close, while they could have made it more coarse and the agents wouldn't have deviated here. So I wanted to give you a quick reality check. As of 2026, as of today, 2026, today we are the 15th, 7, 2026, while I'm recording the following video. There is basically no production library that converts lifespans to XES or OCEL in 2026. The mapping needs to be done by you as an engineer. What does that mean is that it's actually still an open research question. There is no tool out there that does this perfectly. There are many ideas. I actually personally have a project that asks precisely this question, how to solve this, but no one has a 100% foolproof tool. So there is OCEL Gen, which is what we call simulation with process mining. So what it does, it generates synthetic OCEL 2.0 JSONs, and it's not real ones. And what makes it valuable is that it ships ground truth deviation labels. So each event is tagged is deviation, for example, as you can see here, is deviation and deviation type. So you can test your conformance checking against known bad runs before you point it at real data. So what makes it nice is that it loads straight into PM4Py, and you have the following function to do so. And you can think of it as a test fixture. It's not a converter. No one has a converter. And the broad standardization effort when it comes to object-centric event data, OCD, are all open questions for the process mining community. It's still forming. So the bottom line of the whole issue is that the standards are solid. The tooling to reach them from agent traces is still not there. So you as an engineer, you need to figure it out. You need to build your own because there is no one solution that fits everything. So to recap today, we have spoken how the mapping is a convention. How we do it is generally how other engineers did it in other projects, and we just follow them. Of course, you can innovate on them. There is no problem around that. But generally, if you follow them, you're closer to the truth than other situations. Then you have granularity. You can go from coarse to fine, of course. Then we've spoken about XES and also OCEL. Finally, we have shown how PM4Pi has actually the methods to do so. So if you like the content, please like and subscribe and follow me on LinkedIn. Thank you. Next episode will be about how trustworthy is the log.